This is team number 2, explanation of Montante method. We are given the equations 3x plus 2y minus 5c equals 5, minus x plus 4y plus 6c equals 6, and finally 2x minus 4y minus 3c equals minus 10. So with these equations, we are going to build a matrix in this augmented form. The augmented form, we have the results of the equations. So we have also the coefficients. This is how it looks for the system of equations. And then the first step on Montante method is to build a new matrix until it gets like this, where we only have one variable in each equation. So we can solve for x, y, and z, or the variable that we want to choose. So as I said, we substitute the elements on the column by 0 except the pivot, which this is the pivot. We always go from this corner and downwards diagonally through the first or major diagonal, and the row of the pivot will be staying the same. Then, to find the other elements of the new matrix, we will have to perform some operations, which are multiplying the pivot times the element in the previous matrix of the position that we want, and then subtracting the elements that are in the rows and columns of the pivot that intersect with the position of the new element that we want to get. So in this case, we want to get this one. So we multiply 3 times 4 and then subtract 2 times minus 1. I have these operations here. 3 times 4 minus 2 times minus 1 equals 12 plus 2 equals 14. And why do we divide over 1? Well, in the Montante method, we have to divide always by the previous pivot. But in this case, since this one is the first matrix, we have no previous pivot. And we continue to do these operations for the next elements. We have 3 times 6 minus 5 times minus 1, which will be this element. In the end will be 13. Then 3 times 6 minus 5 times minus 1, which will be 18 plus 5 equals 23 over 1 equals 23. Continuing, we have 3 times minus 4 minus 2 times 4, 2 times 2 equals minus 16. We also should divide over the pivot, but since this one is the first matrix, it is not really necessary to put. And then the next element will be the minus 3. We have 3 times minus 3, and then subtract 2 times minus 5, which will be minus 9 plus 10 equals 1. Finally, we have the last element that we wanted to get for that matrix, which will be 3 times minus 10 minus 5 times 2 equals minus 40. And then we continue doing these steps repeatedly until we end up with a matrix like this. In the new matrix, we have to pick the next element of the diagonal, which will be 14, and repeat the same process. Substitute the elements of the column by 0, and then the row will stay the same, the row of the new pivot, and we will do the same operations. Also, the last pivot in that position, we will continue and substitute the value of the actual pivot or the current pivot. So now we continue. We multiply 14 times negative 5 and then subtract 2 times 13. Have it here. 14 times minus 5 is minus 70, and then subtract 2 times 13 minus 26 equals minus 96. And then we have to divide by the previous pivot, which was 3, the previous pivot. So 96 minus 96 over 3 equals minus 32. We put that in the matrix, and we continue doing this method. Minus 14 times minus 40, we want to get this element in this position for the new matrix, and then we subtract the element that correspond. In this case, as the new element is here, it will be minus 16 because it's in the column of the pivot, and 23 because it intersects also with the element. So this will be minus 560 plus 368, that equals 192, and we divide by the previous pivot, which is 3. We have minus 64. Then we have the other element, which will be 74. Here we have it, 14 times minus 1 times 1 minus 16 times 13. This will be equal to 22 over 3, 222 over 3. And then that equals 74. Then in the next step, we have to find the last element of this matrix to complete it. And 14 times 5 minus 14 times 5 minus 2 times 23. This gives us 24 over 3 because we have to divide by the previous people. And this division gives us 8, which is the last element of the matrix. Finally, the last matrix, because we have no more variables, we substitute the diagonal by our new pivot, which will be 74, which is because it is the next element in the diagonal, and the column we substitute by zeros. Then we do these operations on these two positions, which will be 74 times 23 minus 13 times minus 64. Here, 74 times 23, 1702 minus 832 equals 2534. Then we divide it by 14 because it is our last pivot, and we have 181. So we plug it in that position, and we continue for the last element. We have 74 times 8 and subtract 64 times minus 32. This will give us minus 1456 over 14. This equals 1 minus 104. So we have that new matrix, which will be the last matrix in this case. And we have three equations because a matrix can also interpret equations. This is a regular matrix. So we have 74x, because it was the row that was for x coefficients, equals negative 104. We substitute and simplify, and we get this answer for x. We do the same with y. We have this, and then with c, we have this. These are the simplified answers, and then we can plug them in the equations to verify if they are correct. So then, I plugged it in the second equation, which is minus x plus 4y plus 6c equals 6. Plugging in, we then equal the denominators to add them up. We multiply the coefficients to their corresponding variables. And in the end, after all this sum and subtraction, we have 444 over 76. That division gives us 6. Therefore, 6 equals 6. And we can contribute and conclude that this is actually the value of our variables, or x, y, and z.